Okay, the next concept in this section is converting from standard form, y equals ax squared plus bx plus c, to vertex form, y equals a quantity x minus h squared plus k. Okay, how do you do that? You're gonna have to go complete the square. So let's do it that way first. Then I'm gonna show you an easier way.
Why is the easy way always come last?
Yeah, you have to appreciate the easy way. Okay, here we go. If I write it 3x squared minus 6x plus 1. To complete the square, you're going to factor out a 3 with the two terms that have an x. So you have to factor out the leading coefficient. You see, if I distributed the 3, I'd get 3x squared minus 6x. Okay, then you're going to write plus blank and minus blank. I'm going to add and subtract the same number on the right-hand side. So I'm not going to change anything. Now, how do you get that number? You're going to take the b, that negative 2, you're going to multiply it by a half and square it. So you're going to say 1/2 times negative 2, and then you want to square it. 1/2 times negative 2 is negative 1. Negative 1 squared is positive 1. So I'm going to add 1 right here. Now, did I actually just add 1? Don't forget about that 3 there. I really added 3. So I have to say minus 3. Everybody says, whoa. To say that again, you're going to have to take half of this term and square it. That's how you get that first blank here. But you didn't really add 1. You added 3 times 1. So you have to subtract 3. So that you really did nothing to it. Okay, now I have y equals 3 times, if I go factor x squared minus 2x plus 1, I get x minus 1 quantity squared. How did I do that? I factored. If you don't believe me, what's x minus 1 times x minus 1? X squared minus x plus 1, which is x squared minus 2x plus 1. You agree?
Yes.
That's what that was. That's why we just did what's called completing the square. Okay, what's at the end?
Minus 2.
Minus 2. From here, can you tell me what the vertex is?
Negative 1, negative 2.
Almost.
Negative 1.
Vertex.
Positive.
Positive 1, negative 2. You've got to do the opposite of the, you've got to do x minus h, so take the opposite. What else are we supposed to find? The y-intercept? Y-intercept is going to be 0 something. Okay, if it's in standard form up here, when I plug 0 in for x, what do I get? 1. Finding the vertex in standard form is a whole lot quicker. But if you were using vertex form, you would say y equals 3 times 0 minus 1 squared minus 2, which is 3 times negative 1 squared is 1, and 3 minus 2 is 1. There's the y-intercept. I'm going to go ahead and plot these. 1, negative 2 is here, and the y-intercept is 0, 1 here. Okay, my axis of symmetry, where is it? It goes through my vertex, right? So the axis of symmetry is x equals Positive 1. Good. So if I know that that line is the line of symmetry, this purple dot, I've got another one where? At 3, 1? No, sorry, 2, 1. I'm going to do a quick sketch. Vertex, Y-intercept, and axis of symmetry. Questions?
I have one.
Yep,
Are we doing some with fractions after this?
we may.
Okay, good. I knew another.
All right. Another way to go from standard form to vertex form. You ready? The example is 3x squared minus 6x plus 1. Right off the bat, what is A?
3.
3. Okay. Next thing we want to do is find the vertex. To find the vertex, the x value is negative b over 2a. Okay, back up here to the equation. What was a? 3. B is almost negative 6, and c is 1. Okay, what is negative b over 2a?
Negative 6 over 6.
6 over
Negative
2 times 3.
6.
What is 6 over 6? 1. So for the vertex, the x value is 1. If I know the x value, could I go find the y value? Absolutely. What am I going to do with this? Plug it in. What do I get? 3 times 1 squared minus 6 times 1 plus 1. 3 minus 6 is negative 3 plus 1 is negative 2. What is my vertex? 1, negative 2. Is that what we got up here when we completed the square? Cool. Okay. Could you write it in vertex form? You know what A is, and you know what your H and K are.
Yes, sir.
Yes, you can. Okay, your equation says y equals a x minus h squared plus k. Here's RARG.
Just
Plug and chug. Here's your a, here's your h, here's your k. So I get y equals 3 x minus 1 squared plus negative 2. So if you do not like completing the square, if you don't like doing that, you need to be able to identify A, and you need to remember to find the vertex, x equals negative b over 2a. Once you get the x value, how do you get the y value?
You plug in the x for this.
You go plug in that x value into your equation. And then you use that formula. Okay, amazingly, they tell you in the next section, find the vertex of a parabola. Vertex is a point, correct? What is the x value? Negative b over 2a. How do you get the y value? You plug that value into your function. It's f of negative b over 2a. So go find the vertex of y equals negative x minus 4x minus 7. Okay, here we go. What is A?
A is -1.
Negative 1. What is B? Negative 4. And what is C? Negative 7. So for my vertex, the x-coordinate is negative B over 2A. The opposite of B would be positive 4 over 2 times negative 1. So 4 over negative 2 is negative 2. To get the y value, I need to go plug that value in that I just found into my equation, my function. I get negative 2 squared minus 4 times negative 2 minus 7. Negative 2 squared is 4, so I have negative 4 plus 8 minus 7. Negative 4 plus 8 is 4. 4 minus 7 is negative 3. What is my vertex? Negative 2, negative 3. Okay, if I wanted to write this equation in vertex form, I would get y equals negative 1, that's my A, x minus h, so x minus negative 2 becomes x plus 2 squared, plus k, so plus a negative 3 becomes minus 3. This equation and this equation are the same parabola. Could you tell me quickly what is the y-intercept? It's going to be 0, negative 7. How did I get that so quick? In the standard form, let x be 0. Could you tell me what is the axis of symmetry? It's x equals negative 2. Yep. Does this parabola open up or down?
Down.
Why? A is negative, so it opens down. Could you go graph this real quick?
Yes.
Sure. Let's go graph it. I'm going to scoot this down because I can. Okay, if I wanted to go graph that, what is my vertex? Negative 2, negative 3? My vertex is here. My y-intercept was 0, negative 7. So my y-intercept is here. You told me it opened down. I had my vertex was negative 2, negative 3. My y-intercept was 0, negative 7. I knew because A was negative that it opened down. So starting at the vertex, I've got to go down. My axis of symmetry is where? X equals negative 2. How many X-intercepts are there?
0. No. Yeah, 0.
None. It opens down and the vertex is below the x-axis, right? There's not going to be any x-intercepts. So here's the next question. How can you, by just looking at the equation, tell if there are going to be any x-intercepts or not?
Depending on where it opens at, the middle.
It depends on where the vertex is and where it is in location to the x-axis, but we can go do it this way. We use what's called the discriminant to determine the number of x-intercepts.
Is that the hard way?
Well, I think it's a hard way because I just go graph it on my graphing calculator and look and see if it crosses the x-axis, right?
Yeah.
Yeah. Okay, but then what if I say to find the x-intercepts? Then you have to do it this way. All right. Insert new page. Before I go talk to you about this, whenever you're finding the x-intercepts, for example, what was the one up above? Negative x squared minus 4x minus 7. If I wanted to find the x-intercepts, do you remember the quadratic formula?
Maybe. Oh,
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's called the quadratic formula. You're going to use the quadratic formula to find x-intercepts. Now, this piece underneath the radical, b squared minus 4ac, that has a special name. It's called the discriminant. And that little box tells you if the discriminant is equal to 0, the graph has one x-intercept. Because if you were to say plus or minus 0, that's just 0, right? So you would get negative b over 2a. Oh, wait a minute. Negative b over 2a. What is that? That's the x value of my vertex. So, up here by this box, if your vertex is on the x-axis, how many x-intercepts will you have? 1. And your discriminant will be equal to 0. Okay, if your discriminant is positive, whatever you get under the radical is greater than 0, you're going to have 2 x-intercepts. If your discriminant is negative, can you take the square root of a negative number and stay real? No. You're going to have no x-intercepts. So the example that we're doing, we're in the process of doing, this was the graph for it, right? How many x-intercepts should we have? 0. So what do we think that the value of the discriminant will be? A negative number. Let's go see if that's true. Okay, we have x equals negative, what was a? Negative 1, b is negative 4, and c is negative 7. X equals negative b plus or minus the square root of b squared, 16, minus 4 times negative 1 times negative 7 all over 2 times negative 1.
which is negative 2.
So I get 4 plus or minus the square root of, what is that, 16 minus 28 underneath there?
Yeah.
So negative 12.
Can't have a negative.
Cannot have a negative under the radical, so there are no x-intercepts. And it's because of that value. It's negative.
No negative.
Got it? Yep. Okay, let's go back up to these two examples. How many x-intercepts does this quadratic function have? Y equals 3x squared plus 12x plus 5. Before we start, what is A? 3. What is B? 12. And what is C? So I need to go look at b squared minus 4ac. B squared is 144 minus 4 times 3 times 5. So 144 minus 20 times 3 is 60. What is that, 84? Is that equal to 0, positive, or negative?
Positive.
It's positive. So how many x-intercepts do I have?
2.
2 x-intercepts. What are the x-intercepts? We're not finding them right now. I just want you to tell me how many there are.
Wait, what? I don't really think I went in the pursuit to find it.
Could you find the y-intercept on that one?
Yeah.
What is the y-intercept? 0, 5. But you can't look quickly and find the x-intercepts. You're going to have to go use the quadratic formula. Okay, on B, what is A? Negative 1. What is B? Negative 4. And what is C? Negative 5. So go find the discriminant. B squared minus 4AC. B squared is 16 minus 4 times negative 1 times negative 5. I get 16 minus 20, which is negative 4. How many x-intercepts will I have? None. Quickly looking, what is the y-intercept?
0, negative 5.
0, negative 5. Good.